Hi students, hope you have all done the previous sum. Here is your second sum. So the question, find the inverse if exist. The question is, find the inverse if exist. You are having three subdivision under the second sum. So see, first sum is minus to 4, 1 minus 3. Here 2 cross 2 matrix. So I am taking my given matrix as A. So let A equal to minus 2, 4, 1, minus 3. So what is the question? Inverse. So for finding the inverse, this is the formula. So A inverse equal to 1 divided by determinant A into adjoint A. For finding inverse, this is the formula. A inverse equal to 1 by determinant A into adjoint A. So I'm going to find what are the things in the formula you have. I'm going to find all those things. Okay. For finding inverse, you have to first find the determinant value. Alright. In the question, in the bracket they have given if exist. If it is not exist means you don't want to find inverse and all. But if it exists means we have to find the inverse. For that only, we need to first find out determinant A. Alright. So first determinant A is nothing but first value. So if I take minus 2 means the same thing only, your corresponding row and column will be deleted and the rest of the element. What is the element? Minus 3. So minus 2, minus 3. And joining these two elements now, what is the symbol I told already? Minus. So minus 4 into 1. Just the cross multiply. That's it. See. Since it is 2 cross 2 multiply, so I'm just cross multiplying. So minus 2 into minus 3. 4 into 1. So symbol is minus. So minus 2 into minus 3 is what? Plus 6. And here it is 4 into 1 is 4. The minus sign is here. So minus. So 6 minus 4 is what? 2. So what is my value? Determinant A equal to 2. So that is not equal to 0. So I am getting some value other than 0 for my determinant A. So if I don't get 0, my A inverse exists. If I get my determinant value is 0, A inverse does not exist. That is the sum. So for this sum, A determinant equal to 2. So that is not equal to 0. So A inverse exists. So what is the next thing? I need to find out adjoint A. Now see, if I'm finding determinant A and my value is getting 0 now, my A inverse does not exist. We don't want to find adjoint A and all. But here I'm getting my determinant A equal to 2. So I'm getting the number other than 0. So I'm going to find out A inverse. So what is the next value? Adjoint of A. So adjoint of A means what? We need to find out cofactor of A. We have done the previous sum and all the cofactor, right? So the cofactor I'm directly done here. Minus 3, minus 1, minus 4, minus 2. So 2 means I have to, for cofactor, we don't want to take the first element. But for determinant, we want to take the first element. Alright. So cofactor of A na, if I take first element means the corresponding column and row get deleted. The remaining element is what? Minus 3. So minus 3. And if I take 4 means the corresponding element for 4 is 1. So as I said already, what are the symbols? Plus, minus, minus, plus. These are symbols we're going to use. So minus 3, minus 1. And if I take 1 means the corresponding column and row get deleted. My value is 4. So what is my symbol? Minus, so minus 4. And if I take minus 3 means the corresponding column and row get deleted. And what is my number? Minus 2. And your symbol is plus. So minus into plus, you will be having minus 2. So what is adjoint of A? We need to transpose the cofactor of A. So transpose means what? The row value becomes column. So see, minus 3, minus 1 and minus 4, minus 2. So now I've found out the value for adjoint of A and determinant of A. Now we're going to substitute determinant and adjoint of A in the formula. So see, A inverse equal to 1 by determinant A, right? What is determinant A value? 2. So 1 by 2. And what is adjoint of A here? Minus 3, minus 4, minus 1, minus 2. And that is your final answer. That's all. Alright. The second sum is C. This is 2 cross 2 matrix. this is 3 cross 3 matrix. So your question is, I'm taking my given element as A. So the given question is A. So what is my A inverse equal to 1 by determinant A and adjoint A. So again the same thing, for finding inverse we need to first find the determinant value. After that only we go to adjoint of A. So determinant A equal to what? Determinant A equal to the first element, that is 5. So we are, for determinant we have to take the element which we are taking. Alright, so 5, the corresponding column and corresponding row get deleted. So what are the values we have remaining? So 5, 1, 1 and 5 that I have written in the determinant. See, 5, 1, 1, 5. So what is the symbol? Plus, minus, plus, minus, plus, minus, plus, minus, plus. So I'm going to use these symbols. So what is my next symbol is minus. So minus, what is my next number? 1. So if I take 1 means the corresponding row and column get deleted. So what is the remaining element? 1, 1, 1, 5. So 1, 1, 1, 5. The next symbol is plus. So plus, what is my third element? 3. Sorry, 1, 1. And the corresponding column and row gets deleted. So 1, 5, 1, 1. See, 1, 5, 1, 1. Alright, we're going to find out only determinant A. So first row is enough for finding determinant A. We're not finding the cofactor, we are finding determinant. For finding determinant, only first row is enough. Alright, so 5, and what we're going to do? Cross multiply. So 5 into 5, 25. 1 into 1, 1. The number symbol is minus. So 25 minus 1. And here it is minus 1. See, 1 into 5, 5. 1 into 1, 1. And the symbol is minus. And 1. 1 into 1, 1. Minus 5 into 1, 5. So I'm going to solve. 25 minus 1 is 24. Minus 1. And the bracket terms only I'm solving first. So 5 minus 1 is 4. Plus 1, and 1 minus 5 is minus 4. So I'm going to multiply the inner terms. So 5 into 24, 120, and 6. 5 into 24, 120, and minus 1 into 4 is minus 4. And again here is also you'll be having 1 into minus 4, that is minus 4. So minus 4 is what? Minus 8. So I'm going to subtract the value. So 120 minus 8, which gives you 112. That is not equal to 0. What is said already? If I get my determinant A is value other than 0, I should get the value other than 0. If I get the value other than 0 means my A inverse exists. If I get the value of determinant A is 0 means my A inverse does not exist. Here my A inverse exists. So what I need to find? Adjoint of A. Since here it is 3 cross 3 matrix, for adjoint of A you have to find out the cofactor of A for all the 3 rows. See, cofactor of A. I have done here directly because we have done so many sums. So I have done here directly. See, here is 5. If I take my first elements, means for cofactor we don't want to take the elements and all. For the corresponding elements only we need to take. Alright, the first elements we don't want to take. So if I take 5 means the corresponding column and row get deleted. So 5 into 5, 25. 1 into 1 you'll be having 1. So 25 minus 1. So see, here it is 25 minus 1. Similarly I've done all the values and deleting the corresponding rows and columns. I'll be having this matrix. So after that I'm solving the value. See, 25 minus 1 is 24. And first we need to find out the bracket values. After that only we need to join the values with the symbol. So 5 minus 1 is 4. So minus 4. And 1 minus 5 is minus 4. So similarly first we need to find out the bracket value. So 5 minus 1 is 4. Since here it is minus, so I'll be writing it as minus. So 25 minus 1 is 24. 5 minus 1 is 4. and the outer side is minus, so minus 4. Here it is 1 minus 5 is minus 4, 5 minus 1 is 4, and here it is minus, so minus 4, and this gets 24. So I found out the value of cofactor of A. As soon as you found out the value of cofactor of A, you need to find out. We got the cofactor value, so as soon as we got the cofactor value, we need to transpose the given value. So transpose means what? The row values will be column. So adjoint of A equal to C, 24 minus 4 minus 4, this is the row. So I'm writing it is in the column way. So I'll be having this matrix. So at last I found out the value of determinant A and adjoint of A. Determinant A is 1, 1, 2, and adjoint of A is this matrix I've written here. So see, in this matrix I'm going to take the common element. So what is the common element here? I'll be having 4, because 24, 4 and 24, 4 only I'll be having this matrix. So I'm taking 4 as common. So if I take 4 as common means the inside matrix I'll be having, here it will be 6, and this is minus 1, here it is minus 1, here it is minus 1, because I'm taking 4 here. So 4 if I take common means I'll be having only 1. So if I take 4 outside means I'll be having here it is 6. So then it will become 4 6 are 24. Like that we should take. So again minus 1, this becomes minus 1, and it is 6. So I'm going to cancel the outer part. So I'll be having 4 ones are 4, 4 28s are. So my value will be 1 by 28, and this matrix, this is my A inverse. Alright. So we need to, since this is 3 cross 3 matrix, we need to find out cofactor for all the 3 elements. So I've done the second sum and your first sum. So first and second subdivision I've done. You can work out the third subdivision as a homework sum. So third subdivision you can work out. You need to see, first thing is you have to find out the determinant value. If you get the determinant value is 0 means you don't need to find A inverse and all. That's it. A inverse does not exist. That's it. If you got the value of A, determinant A, if you got any value other than 0 means you have to proceed with adjoint A and all. Alright. Try to do the second sum, and your third sum is if f of alpha equal to matrix cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha, we need to show that f of alpha the whole inverse equal to f of minus alpha. This is the question. What I need to prove? F of alpha the whole inverse equal to f of minus alpha. So first I'm going to take the inverse part. So inverse part means what? What is the formula for finding inverse? So A inverse equal to 1 by determinant A into adjoint A. This is the formula for finding A inverse. But see, if I take the given element is A means I have to write here it is A inverse. But here what they've given? F of alpha. So I need to write it as f of alpha the whole inverse equal to 1 divided by determinant of f of alpha into adjoint of f of alpha. This is how I should write. So see here what is supposed to find first? Determinant f of alpha. So what is determinant f of alpha? The first element. If I take first element means the corresponding column and row deleted. So balance 1 into cos alpha minus 0 into 0, 0. The next part is 0. So if I take 0 means the corresponding column and row gets deleted. See 0 in cos alpha is 0 and 0 in sin is 0. So everything's become 0. So I have written only 1 0. You have to suppose to write the symbols. Okay. So this is plus minus plus minus plus minus plus minus plus. So minus 0. The next element is what? Plus sin alpha. So the corresponding column and row gets deleted. So 0 into 0 is 0. 1 into minus sin alpha is minus sin alpha. So you have to combine the two numbers with 1 sign, right? That is minus. So minus into minus plus 0 minus sin alpha. How this comes means 0 minus of minus sin alpha. So minus into minus what? Plus. So I've written directly. Okay. So see, cos alpha minus 0 is what? Cos alpha. So cos into cos, I'll be getting cos square alpha, and this 0 will be deleted, and here it will be 0 plus sin alpha is what? Sin alpha. So sin into sin is sin square alpha. What is the formula for cos square theta plus sin square theta? You'll be having 1. So cos square theta plus sin square theta means value is 1. Instead of theta, you'll having here it is alpha, but the value is same only. So cos square alpha plus sin square alpha equal to 1. You got the answer is 1. So what is my determinant of f of alpha is 1. That is not equal to 0. Therefore what? My inverse exists. As soon as my inverse exists, means what I supposed to find out next is adjoint of f of alpha. So see, for finding adjoint of f of alpha, we need to find the cofactor first. See, I have written directly because we have done already so many of sums based on cofactor. So I have written directly. If you want, you can work out it and see, right? So minus, what the answer I got is minus cos alpha 0 sin alpha 0 1 0 minus sin alpha 0 cos alpha. As soon as you find out the value of cofactor means we need to transpose the cofactor of matrix. So if I transpose means what the value got? I'll get cos alpha 0 minus sin alpha. See, my column part become row part and my row part become column part. That's it. So cos alpha 0 minus sin alpha and 0 1 0 sin alpha 0 cos alpha. So I got the value of adjoint of f of alpha. So I need to substitute in the formula. So what is the formula? F of alpha, the whole inverse equal to 1 divided by f of alpha adjoint of f of alpha. So that is my LHS part, right? See my LHS. So f of alpha, the whole inverse equal to 1 divided by, what is the determinant of f of alpha? 1. So I'm going to substitute here it is 1 into adjoint of f of alpha. So I'm going to substitute my adjoint value here. I'm going to consider that is my first equation. That is LHS my first equation. And the rest I'm going to find out f of minus alpha. F of minus alpha is nothing but the question here it is f of alpha. But what we need to find here it is f of minus alpha. So wherever you will be having alpha in the question, you need to just substitute minus alpha. That's it. That is the meaning of f of minus alpha. So what is my RHS? F of minus alpha equal to cos minus alpha, sin minus alpha, and this central as it is, because wherever you'll be having alpha, that only going to change. See, for cos and sin only you'll be having alpha, so that part only becomes minus alpha. So minus alpha, here also minus sin minus alpha and cos minus alpha. So see, in the trigonometric function you'll be having, if we have sin minus x means that can be written as minus sin x. Your minus should comes the beginning of the function. So minus sin x. But in case of cos value, cos minus x will becomes cos x, because cos brings always the positive values and sin brings always the negative values. So sinus minus x equal to minus sin x, and cos minus x will be cos x. See, in case of alpha, the same thing only. So what is the value becomes? So cos minus alpha becomes cos alpha, and 0 the same, but sin minus alpha becomes what? Minus sin alpha. And here it also 0 1 0 as it is, and here already you'll be having 1 minus outside. So what is the value for sin minus alpha? You'll be having minus sin alpha, right? So already minus you'll be having outside, and here it is minus. So minus into minus plus sin alpha. So 0 again, cos minus alpha equal to cos alpha. So I'm going to consider that as my second equation. See, the trigonometric function carries sin minus x means you will be having minus sin x. Cos minus x means you will be having cos x. So I'm going to introduce these values for this function. So cos minus alpha means that is cos alpha, that is positive function. Sin minus alpha means that is negative function. So minus sin alpha. in this value we'll be having already minus in this part. So one more minus we'll be getting for solving sine minus alpha. So minus sine alpha means minus into minus plus sine alpha. So I'm going to consider that as my second equation. Now see the LHS and RHS, both are equal value. So I'm going to conclude that LHS is equal to RHS. So we showed that f of alpha power minus, f of alpha the inverse equal to f of minus alpha. So that's all your third sum. So I'm moving to the next sum, that is fifth sum. You can work out and see the fourth sum because that is same thing only. You need to only find out the inverse and adjoint, that's only. So this is the different sum. I'm going to do the fifth sum. You can download the book from your net, so you can find out the question from that. Try to work out the fourth sum. Well, let's see your fifth sum. If A equal to 1 by 9 and your matrix given here it is minus 8, 1, 4, 4, 4, 7, 1, minus 8, 4, is supposed to prove that A inverse equal to A transpose. This is the thing we need to find out. See, if A equal to 1 by 9 matrix minus 8, 1, 4, 4, 4, 7, 1 minus 8, 4, we need to prove that A inverse equal to A transpose. So for finding A inverse equal to A transpose means we don't want to find the A inverse means we need to suppose to find out, right, determinant A, adjoint of A, because the formula for A inverse equal to 1 by determinant A into adjoint A. This is the formula, but we don't want to find this part, because if your question is in this way, A inverse equal to A transpose means that should be written. So I'm taking my this A inverse to this side. So if I take means my part will be A. This A inverse becomes A into A transpose, which is equal to I. This is the way I should get. See, if I take A inverse this side means I'll be having that it as A. So A into A transpose equal to my I value. From this we can find out the value of A inverse equal to A transpose. So first I need to find out A transpose, because A transpose is AC value, right? So A transpose is what? 1 by 9. The outside is same only, but the matrix part will becomes, the row will becomes what? Column. See, minus 8, 1, 4. There it is in question, the row, but the answer I'll be having in the column part. So minus 8, 1, 4, and the second row is 4, 4, 7. See, 4, 4, 7, and my third row is 1, 8, 4. So I'll be having this in the column 1 minus 8, 4. So I'm keeping this as it is. Alright, so that is my A transpose. What I said, I need to prove A into A transpose equal to I. That is enough. Alright, because we can prove either the A inverse equal to A transpose, otherwise A into A transpose equal to I. Everything is same only. So what I think is this part is easier, right? So A into A transpose equal to I. I means what? Your identity element. So what is my A? That is my question. So I'm going to substitute here, say 1 by 9. I'm going to write the question directly into my A transpose value, that is this value. In both A and A transpose, what will be having? 1 by 9 you're having. So I'm writing 1 by 9, the question part, that is your A value, into your A transpose value. Now say you're having 1 by 9. So everything is in the multiplication only. So 1 by 9, and here also you'll be having 1 by 9. So 1 by 9 into 1 by 9 is what? 1 by 81. Now I'll be having the matrix part alone, because I've solved the values which is in the outside the matrix, right? So 1 by 9 into 1 by 9 is 1 by 81. So I'm going to multiply the matrix part. So how will you solve the multiplication? Because you have done already in the 10th standard and all. So we have to multiply the row with the column. See, the first element, the second, and with the second, and third with the third. Similarly, we have to do the first row with the second column and the third column. Now see, minus 8 into minus 8 is what? Plus 64. 1 into 1 is plus 1. 4 into 4 is plus 16. Similarly, I'm going to do it for second column. So minus 8 into 4 minus 32. 1 into 4 plus 4. 4 into 7, 28. For multiplication, you have to multiply only the row with the column, not with the row. Alright, the row should be multiplied with the first column, and similarly the second and third column. That should be written in the first row. Next, minus 8 into 1, minus 8. 1 into minus 8, minus 8. 4 into 4, 16. So I've completed the first row. Now we need to multiply the second row with the same, the columns. So 4 into minus 8, minus 32. 4 into 1, 4. 7 into 4, 28. Again 4 into 4, 16. 4 into 4, 16. 7 into 7, 49. See, 4 into 1, 4. 4 into minus 8, minus 32. 7 into 4, 28. So second row gets over. So next is third. Third with the 3 columns. So 1 into minus 8, minus 8. Minus 8 into 1, minus 8. 4 into 4, 16. And 1 into 4, 4. Minus 8 into 4, minus 32. 4 into 7, 28. 1 into 1, 1. Minus 8 into minus 8 plus 64. 4 into 4, 16. So I have completed all the 3 rows. So I am going to solve this matrix. See, if I add these 3 ones, I will be getting 81. And here, so here it is minus 32. Here it is 28 plus 4 is 32. So minus 32 plus 32 is what? 0. Next, here it is minus 8, minus 8. So minus 8 is minus 16. So minus 16 plus 16 is again 0. And again 6. 4 plus 28, 32. So minus 32 plus 32 is 0. And this part, whole part becomes 81. And this will become 0. Minus 8, again minus 16. So minus 16 plus 16 is 0. And 4 plus 28. So I'm going to first take the similar symbol. So that is plus 4 plus 28. So plus 4 plus 28 is what? 32. Already I will be having minus 32. So 32 minus 32 is 0. And this part becomes 81. Alright. So what is the common term you will be having in this matrix? 81 is the common. So you will be having 3 rows 81. So I'm taking the 81 outside. So what I will be having if I take 81 outside? If I take 81 outside, already you will be having one more 81. So inner part becomes 1, 0, 0, 0, 1, 0, 0, 0, 1. So if I cancel means what is the value? 1, 0, 0, 0, 1, 0, 0, 0, 1. What is that is? This is my identity element. So I'm writing here it is I3. 3 is nothing but 3 cross 3 max. So I'm writing it as 3I3. If you write I, that is enough. So no need to worry anymore. So A into A transpose equal to your I value. That is identity element. Identity element is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1. So similarly, so I found the 1 value, right? A transpose equal to I3. So if I multiply A transpose with A is also, I will be getting I1 only. We don't want to solve this thing. Just we write similarly, that is enough. So A transpose into A is also, you will be getting I3. So from the orthogonal part, what I am going to conclude is, see, the first part is A into A transpose. The second is A transpose into A. Both the values I am getting what? The answer is I only. So I'm going to write it as together. That is A into A transpose. That is this value going to equal with this value, because on the same answer only I'm getting, no. So A transpose into A equal to I. And this is called as orthogonal. We have come across the orthogonal. So orthogonal value. So that can be written as A inverse, which is equal to A inverse A, which is equal to I. if I multiply A with A inverse also, we'll be having the answer as I. But we don't want to find out because we have this into the formulas. You'll be studying in the book, the result part, you'll be studying all those things, okay? So you can go through the front part of your book, you'll be seeing all those formulas. So A transpose equal to A transpose A equal to I, and A inverse equal to A inverse A equal to I. So see, if I take any one part, because everything is equal only, because I'm getting the answer is I only. So if I take any one part, so like A transpose equal to, and this with this one. So A inverse, because both the things are I only. So if I cancel A means, so what is the answer I'm getting? A transpose equal to A inverse, which I need to prove. That only, right? A transpose equal to A inverse. That is the thing only I'm getting. So what I'm going to conclude is my A inverse equal to A transpose. That is proved. This is called as orthogonal part. See, for finding A inverse equal to A transpose, we don't want to take the formulas and all. This is enough. So A into A transpose equal to I. This is enough for finding this sum. Alright. So this is the value. So A into A transpose equal to I. So that is the answer for this sum. This is called as orthogonal. So we have proved A inverse equal to A transpose. Hence proved. That's all of the sum. So if you need to prove A inverse equal to A transpose means this is enough to show, that is A into A transpose equal to I. Alright. So first A transpose I'm finding. So A transpose is nothing but changing the rows into columns. So I've changed the rows into columns. After that I'm going to multiply my A transpose with A. So A transpose with A means if I multiply, I'll be getting the answer like this. So I'm taking my 81 as common. So if I take 81 as common, the remaining matrix will be 1 0 0 0 1 0 0 0 1. That is nothing but my I. I is my identity element. So I'm going to conclude that A transpose equal to I. So similarly, you don't want to find out these things. You just write similarly. That's enough. So A transpose A equal to I3. So what I'm going to tell is A into A transpose, and A transpose equal to I, because both the answers equal only. So I'm going to combine these two. So A into A transpose, which is equal to A transpose into A, which is equal to I, that is orthogonal. And also you're having A inverse equal to A inverse A equal to I. This also you don't want to prove, because this in all formulas you'll be having in the beginning of the matrix, that is in your first page of your book you'll be having. So you just write this, it's just enough. You don't want to prove again. So if I take the first part, see, because both the things are equal only, if I solve I'll be getting identity element only. So I'm going to take these two. So if I take these two means I'm cancelling A and A. So I'll be having A transpose equal to A inverse. That is the thing you need to prove. That is true. So this is your fifth sum. So you can work out the sixth and seventh sum, because sixth and seventh sum is same as the previous sums. So I'm not going to do. You can work out and see. If you have any doubt, you can leave it in your comment box. I'll try it. I'll explain you. Alright. So next is your eighth sum. That is I'm going to move on to eighth sum. So if adjoint A equal to 2 minus 4 2 minus 3 12 minus 7 minus 2 0 2, find A. See, previous sums and all, the question given there is A value and we need to find out adjoint value. But here see, that is totally opposite. The given value is adjoint. We need to find out A. So see the second formula. So what is that? A equal to, for finding A, if your question is adjoint A means, this is the formula for finding A value if your question in the form of adjoint A. So A equal to plus or minus 1 divided by, see carefully, it is square root of determinant of adjoint A. See, I have introduced two symbols here. So square root, and inside the square root what you will be having? Determinant of adjoint A into adjoint of adjoint A. This formula is little confusing only, but see, for finding A, you have to use this formula only. See, plus or minus 1 divided by square root of determinant of adjoint A into adjoint of adjoint A. Same thing only. So if this means what we need to find out first? First determinant only we need to find. So determinant of adjoint of A. Adjoint of A is nothing but it is in your question. See, adjoint of A, right? The question is given as adjoint of A. So I'm going to take the determinant value for your adjoint of A. So how will you take? You have to take the first element. So if I take first element means the corresponding same thing, the corresponding column and rows deleted. So balance 12, minus 7, 0 and 2. And see what is the symbol. So plus minus plus minus plus minus plus minus plus. So see, second one is minus 4. Already in the symbol you will be having minus. So what is I'll be getting? Minus into minus plus. This is for finding determinant, not the cofactor. You can mind that. So I'm going to find the determinant value, not the cofactor value. Cofactor means you're not supposed to take the elements, only the corresponding value. That is, see, this beginning element, right? The front elements, that is 2, 4 and 2. These things you should not take it for cofactor, only the determinant part. But for determinant, you need to take the elements. Alright. So the next is 2. The corresponding row and column gets cancelled. So minus 3, 12, minus 2, 0. So I'm going to cross multiply. So 12 into 2, 24. So see, if I multiply 7 with 0 means I'll be getting 0 only. So there is no value. So I'm going to write in only 24. So 12 into 2, 24. Plus 4. So next minus 3 into 2, minus 6. And minus 2 into minus 2 is, minus 7 into minus 2 is what? Plus 14. The symbol I should combine these two values is what? Minus. So I am writing it as minus 14. Listen, in the value minus 7 minus 2. So minus 7 into minus 2 is plus 14. But in order to connect these two elements, I supposed to introduce minus, right? So that minus is writing up. So minus 6 minus 14 plus 2 and minus 3 into 0 is 0 only. So 12 and so minus 2, 24. So that I'll be getting minus plus 24. So 0 minus of minus 24. This is how this comes. So minus into minus plus 24. So I'm solving the part. So 24 into 2, 48 plus 4, 6 minus 14. If you have same symbol means what you're supposed to do? You should add. So 14 plus 6 is 20. And after that what you should do? You have to see the greater number. What is the greater number? 14 is the greater number. So what is the sign before the greater number? Minus, so minus 20. So plus if you multiply means 48. So if you solve means I'll be getting the value as 16. So determinant of A equal to 16. So what here they have given? Square root of determinant of adjoint of A. So my determinant of adjoint of A is what? 16. And square root of determinant of adjoint A was square root of 16, that is nothing but 4. After that what we need to find out? See, they have given adjoint of A. This adjoint of A is question. So I need to find out adjoint, right? So cofactor of adjoint matrix. So what? Similarly, the first element if we take means where the corresponding column and rows get deleted and directly have done here. If you have a well practiced with the sum, you can directly do. You don't want to write it the previous step and you can directly come to this step. That's enough. So I've done this matrix by solving the rows and columns of the question. I'll be getting this matrix. So after that I'm solving by the symbols. Whichever you are putting it's really important for the sum, because if you are forget to write the symbol means your total sum gets Wrong. Alright, so the symbol is important for all the values. The in the matrix part you're going to do only the place, addition, subtraction, multiplication, division only. But for that itself you need to concentrate with the symbols. Alright, so see 24 minus 0, 24, and see as I told already, so minus 6 minus 24 is minus 20. Already one minus it's outside, so minus into minus is what? Plus, so plus 20. This is 24. See, minus 8 minus 0 means the answer will becomes minus 8. So minus into minus plus 8. So 4 plus 4, 8. And 0 minus 8 is obviously minus 8. So minus into minus plus. 28 minus 4 is 24 is 4. And you see minus 14 plus 6. So if I get minus means subtract means 8. So what is the greater number? 14. So minus 8. So minus into minus plus 8. So 24 minus 12 is 12. So I got the value of cofactor. As soon as I found out the value of cofactor, I need to transpose the value. So I transposed. So now I got the value of adjoint value I got, and determinant value also I got. So I'm going to substitute all those things in the formula. Right. See, A equal to plus or minus 1 by 1 by 4, and the matrix is 24 8 4 28 8 24 8 12. So see, in this matrix I'm going to take 4 as my common element, because 4 in this values 4 will get cancelled for all the elements. So I'm taking 4 as common, so into 4. So in the inner part will be 6, because for 6 are 24. This is 2, 4 2s are 8, and here it is 4, so 4 1s are 4, and here it is 4 5s are 20, 4 2s are 8, 4 2s are 8, so 5 2 2, 6 4s are 24, so 6 2 3. So if I cancel 4 means the remaining element 6 2 1, 5 2 2, 6 2 3. That is my A value. So A equal to plus or minus 6 2 1, 5 2 2, 6 2 3. That is the final answer. See here, this question is totally different, because in this question the previous sums and all they have given the A value and we need to find out the adjoint value, but here they have given the adjoint value, we need to find out the A value. In order to finding this thing, this is the formula, that is A equal to plus or minus 1 divided by square root of determinant of adjoint of A into adjoint of A. So formula is important for all the sums, so try to remember